fine. So let us start up with the class that is maltose. Okay, maltose. What do you mean by maltose? Maltose is an disaccharide. Okay, maltose. This is the first point. Maltose is an disaccharide. Okay, it is a composition of two glucose unit. Two glucose unit. Maltose is an disaccharide and it is a composition of two glucose units. Okay, it's also said it as malt sugar. It's also said it as malt sugar. It is most oftenly present in the germinated seeds. It most oftenly present in the germinated seeds. Okay. It's having a molecular formula of C12H22O11. C12H22O11. By the formation of the interglycosidic bond between two glucose, one water molecule has been released. That's why it is said it becomes the formula of C12H22O11. Okay, and it is exist in the two structure, that is in alpha maltose and your beta maltose. Okay, alpha maltose and your beta maltose. Okay, and the glycosidic bond links by the 1,4 glycosidic linkage. Okay, it's an 1,4 glycosidic linkage. So the link exists between the C1 and C4. The link exists between C1 and C4. So when it will become alpha, okay, when it will become alpha means when alpha glucose or link, when alpha glucose or link, it will give alpha maltose. When beta glucose or link, it will give an beta maltose. Okay, if it is alpha maltose will link, that will give you an alpha glucose gives you an alpha maltose. Beta glucose give you an beta maltose. Okay, then because of the presence of OH group in the first carbon of your alpha, in first carbon of alpha glucose, you have free OH group. Okay, in the first carbon you have free OH group. That's why this is an reducing sugar. Okay, this is called it as reducing sugar. This is very important question. We are saying instead of free OH group, you can say free aldehydic group. It means to say CHO group. Okay, you can say like that also and like this also, free aldehyde group or free OH group. So now let us write the structure of glucose first. In an open chain structure, let us write the glucose structure. Okay, this is the open chain structure of your glucose. So by this, what happened? The glycosidic bond will link from the first carbon to the fifth carbon, okay, and it will become like this, okay. Are you getting my point? So when two glucose are linked by the Haworth structure, I'll write it here. This is your alpha glucose. Okay, this is your alpha glucose. I'll write the same glucose in the other side. I'm writing the same structure of this. Okay, I'll just number the carbon. Can you able to see? Yes, this is also alpha glucose, and this is also alpha glucose. So by this structure, we can see the two alpha glucose are sat side by side. Okay, sat by side. So what we'll do, we need to link these two with 1/4 carbon. That's why we'll remove this two molecules of OH will leads to the formation of H2O plus O, that O involving in the bond formation, and this H2 will form an one molecule of H2O. That's why glucose having the formula of C6H12O6. This is also same C6H12O6, but if we total this, if we add this like C12H24O12, but we don't get because of this glycosidic bond, because of the removing of water molecule over here, that is 2H and 1O, we are facing the deficiency of 2H and 1O. That's why your maltose formula C12H24O11. Okay, can you able to get it? Can you able to write this? Is it fine? Okay. I wrote this. Shall I move on? Have you copied? Have you copied? Shall I move further? Okay. Fine. Next. Now you need to write beta maltose structure, but I'll give you one hint. In Haworth structure, he told that in first carbon, H and OH will replace. First carbon only HOH position will change. Can you write the beta structure? Can you write the beta maltose? In beta maltose, one is alpha glucose, second one is beta glucose. So this is alpha glucose and this one is beta glucose. So write it fast. Let us see who will write first. I'll write the alpha structure. We just change this first carbon structure. We just change this first carbon structure. Everything remains the same. Okay. Here you should know that here we are saying beta maltose. The bond is not beta, bond is beta alpha only. So here also it will become the same thing. Okay. Are you getting the point? Yeah, Sujan, that's why I told. It is not a beta glycosidic bond. Bond is not an glycosidic, but we are saying we are taking one glucose as a beta form. That's why this maltose will become beta. The bond is alpha only. In your maltose, alpha bond only exists. They can ask you like this: what is the bond exist between in your what is the type of bond exists in your maltose? That is alpha bond. Maltose having the alpha bond only. Sujan, okay? I'm not saying you are glycosidic. This bond is not an beta. Because of the presence of one glucose in your maltose composition, we are saying it's a beta maltose, but it's not an beta glycosidic bond. Okay, okay, no problem. Next, write it fast. We'll move on to the lactose now. Finish. Finished. Okay, now lactose. So here lactose is present in your cow milk. Lactose is present in your cow milk. That's why it call it as milk sugar. That's why it call it as milk sugar. Yes, of course, it's a disaccharide. Okay, it's a disaccharide and it's a composition of glucose plus galactose. Okay, it's a composition of glucose and galactose. And in your milk, 2 to 8% is covered with your lactose. In your milk, 2 to 8% of lactose it's contained. And it's having the molecular formula of C12H22O11. It's having the molecular formula of C12H22O11. And it is exist in the two formats that is same as like we read maltose, that is alpha format and your beta format. Okay. Should I write the structure? Yes, Meghana, you're right. It's a glucose plus galactose gives your lactose. So now let us write the, yeah, anyhow, you know the structure of glucose. And now I'm going to write the structure of galactose. This is an okay. This is an open chain structure of your galactose. You can see here in your glucose, H is present here and OH is here. H is in your glucose, H present here and OH here. But in galactose, it is that's why it's C4 epimer of glucose. Galactose is said to be a C4 epimer of your glucose. So let us write the Haworth structure. Okay, let us write the Haworth structure. First, I'll write the galactose structure. As I informed you. So we are writing an beta galactose. So beta means to say first carbon should change. Yes. It's changing. First carbon, you can see the H here and OH here. Okay, we are writing beta. Beta means to say you can see this is galactose, right? So in your first carbon, it will be like this actually. If it is reverse, if it is ulta, okay, it is like this. If it it is like this after your glycosidic linkage. If it is goes ulta, it will give you a beta structure. Okay, are you understanding? Are you understanding? This is beta galactose I'm writing here, and here you should remember this is changing when you're comparing when you're comparing glucose with your galactose. In your fourth carbon, the changing of glucose with your galactose. But when you're doing an alpha beta changes, that is in the first carbon. You should remember, I'll repeat again. If you are comparing the glucose with your galactose, that is C4. In the fourth carbon, the position of the H and OH has been changed. If you are considered an alpha beta, if you are comparing an alpha with your beta, the changing takes place between your first carbon H and OH. Between your H and OH in your first carbon. Okay. Okay, fine. This is beta galactose. And I'll write alpha glucose. Okay, alpha glucose. Glucose remains the same always. So what happened when beta galactose combine with your alpha glucose, it will give you an alpha lactose. It will give you an alpha lactose. What happened? It will remove like this. So it is N. But the bond is beta. The bond exists is beta. But because of the presence of alpha glucose, it is considered as an alpha lactose. This is called it as alpha lactose. They'll ask you write alpha lactose or beta lactose. You need to write like this. The bond exists between your lactose is your beta bond. Okay, it's a beta glycosidic bond. Okay. So this is your alpha lactose. Can you write the structure of beta lactose? It will remains the same. Okay, this galactose remains the same. You need to change this one. You need to change this one. The position of these two has been changing. That will give you an beta lactose. Please change this structure. Write OH here, H here. Write one more time. Write one more time. You need to change everything remains the same. You need to change only the first position of your beta for your alpha glucose to convert the alpha to beta. Okay, please write it and tell me, ma'am, I wrote. Write it fast. I'm taking attendance, so till that you need to finish. Okay. Have you wrote finished? Finished? Okay. Now let us write the structure of sucrose. Nobody wrote the beta structure. This sucrose is called it as, or it's said it as disaccharide. Yes, you're right. Sucrose is a disaccharide, and it is commonly called as table sugar. So whatever the sugar we are using in our daily life in our home, that is called as table sugar. So that is an sucrose. So it's also known as saccharose. 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 It's also said it as saccharose. Yes, of course, it's an white in color, odorless, crystalline. Okay, crystalline, sweet in taste, soluble in water. Okay, then it can be converted in the form of powder, and it's having the composition of glucose plus fructose. It's having the composition of glucose plus fructose. Okay, glucose plus fructose. And same, it's having the molecular formula of C12, H22O11. Very good, Meghana. Others, everybody are sleeping. So here we're having one small change we need to observe, that here we are not combining the pyranose structure of both. Here we are taking the pyranose glucose and furanose fructose. Here we are taking pyranose glucose with your furanose fructose. And we are not having the free OH or aldehyde group. So that's why it call it as non-reducing sugar. This is the only disaccharide having a non-reducing sugar. Okay. It's the only non-reducing sugar. Fine. So we need to write pyranoglucose with your furano fructose. It means to say this glucose is 6-membered ring and fructose should be in the 5-membered ring. Let us write it. And because of the non-reducing agent, it doesn't give the positive result for your tolerance and for your Fellings reagent. So let us write the glucose structure first. So We are writing alpha. When you are seeing the first carbon, you can notice that whether it is alpha or beta. This is alpha. So because of the betterment of chain, we are writing one next to the other. Okay, we are writing one next to the other. So this is pyranofructose. Can you able to see? So this is, I'll write here, glucopyranose. This is fructofuranose. Glucopyranose combined with your fructofuranose, and same it will become like this. This is called as the structure of your sucrose. Because of the this linkage, it doesn't having the free OH group in the first carbon. That's why we are saying it's a non-reducing sugar. Okay, non-reducing sugar. Okay, you're getting my point. So in sucrose, we don't have alpha or beta structure. We don't have alpha or beta structure. We need to write and sucrose structure as like this. Are you getting my point? Have you wrote it? So yes, by this we'll end up the today's class. You need to work the disaccharides. It's very easy. And we have the inversion of cane sugar. In the next class, we are going to take the inversion of cane sugar. That is how you can convert the sucrose into an monosaccharide. It's a reverse process. You can say like how we can convert the disaccharide into an monosaccharide units. And next we have a polysaccharide structure, that is starch, glucose, sorry, starch, glycogen, and cellulose. So if we are done with this, with the biological importance, we are done with the carbohydrates, then we can switch on to the protein structure. So tomorrow I'll definitely complete the carbohydrates formats. Okay. Is it okay? So we have a time. Let us do one small thing, that is inversion. We have a time, right? We have 5 minutes. So in that I can finish. Inversion of cane sugar, CANE. Cane sugar means your cane. You know that. So we are doing with conversion with your sucrose. So how we can write? So we having C12H22. It is the formula, and when the water molecule is added to it with the presence of hydrogen, it will give you C6H12O6 plus C6H12O6. So this is glucose plus your fructose. Okay. Are you getting mine? How we can say that whether it is glucose or fructose? So we can say whenever we are passing a plane polar light, if it is rotates at the angle of plus 52.5, okay, in the plus means if it is rotate twice, that is 52.5 degree. If it is rotate like this, it is of glucose, and if it is rotate minus 92.5, it is fructose. Sorry, this is not beta, alpha. Both are alpha. Are you getting my point? So when sucrose is added with the water with the presence of hydrogen, if we are breaking the bond, we'll get two monomeric units. One is glucose, one is fructose. One is glucose unit, one more is your fructose unit. Okay, can you see? This is going to ask you for 2 marks question. This is your 2 marks question. Inversion of cane sugar. So nan class alle and meanwhile I am going to say whether it is this question is important and this question is asking for how many marks. Don't ask me again and again, ma'am, please the lesson. I'll inform you. I'll tell you that I told you that already, that I'll inform you in the last session of this academics. So if you are know that, then you won't read the lessons and you won't be able to concentrate for all the things. So that I'll give you everything, including materials also I'll give. You just try to learn the, okay. So when this sucrose is going to add up with the water with the hydrogen, it will give you an glucose and fructose. How we can consider, if we are passing a light, if it is rotates towards clockwise with the 52.5 degrees Celsius, this is called as glucose. If it is rotate towards anti-clockwise, that is for minus 92.5 degree, it is said to be as fructose. Both are in the alpha state. My battery is very low, that's why in the blur. Yes, Nikhil, it's of cane sugar. Okay, sugar cane. Yes, yes, you are sugar cane. So you can ask, and if you're having any doubt, you can ask me or you can send me a message. So thank you so much for attending. Have a good day. In the next week, we are going to write the test for solid state. Get well prepared, and we are back up with one more concepts in the P block elements. Next take up, and we'll do that, no problem. Until that, we complete this biomolecules also, and we can further. So you need to read. You don't have any other option. I think you can understand my class today's class, that we are done with the how we can write the structure of alpha beta structure of lactose and alpha beta structure of your maltose and superstructure and composition disaccharides.